Hello dear students, welcome into the second lecture on pH-Metry. Myself, Mr. M.S. Bale. I am working as an assistant professor at Gokhale Education Society's Arts, Commerce and Science College, Jawar. So, dear students, in the last video lecture, we have seen the principle of the pH metry and its type of pH meters. Okay, in this video lecture, we are going to see the principle, construction, working, and care of combined glass electrode. That means simply we are looking the principle of combined glass electrode, construction of combined glass electrode and its working. And at the end we are see the applications of the pH metry. Okay. First we will see the principle of the combined glass electrode. The glass electrode works on the principle that two solutions has different pH are separated by a thin glass membrane. A potential is set up across the two surfaces of glass membrane. By keeping the pH solution inside the glass bulb constant, the pH of the solution can be determined by measuring the potential. That means inside the glass bulb there will be 0.1 molar SCl solution is there. Okay, that we will see into the diagram in construction. At 298 Kelvin and for a given solution of H plus ion concentration, the potential is given by this Eg, that is EMF of the glass electrode, is equal to E naught G, that is standard EMF of the glass electrode, plus 0.0592 log to the activity of H plus ion, which is gives E naught G minus 0.05921 pH. Log of activity of H plus ion, that will be the pH. Okay, all of you know this is the formula of pH, right? Where Eg is the potential of glass electrode and E naught G is the standard potential of glass electrode, which depends on the type of glass material used for the made of that combined glass electrode. Now we will see the construction. See, in this construction, first we will see the diagram of the combined glass electrode. See, this is the first diagram of the combined glass electrode, and second also the diagram of the combined glass electrode. See, into the first there will be above wires to the pH meter. That means these two wires will be connected to the pH meter. Here there is a filling hole. From the filling hole we can fill the saturated KCl solution inside this part. That will be the reference electrode, which is made up from silver chloride. Okay, and here will be the permeable porous junction. Okay, in this side also silver wire, which is covered by the silver chloride. Okay, and reference electrode, which is internal, which is having internal solution, that will be the KCl solution, right? And at the bottom there will be glass membrane, okay, which is glass electrode, which is having internal solution. That solution will be the 0.1 molar SCl solution. Okay, that will be filled into this glass membrane. Okay, see, in this second figure also there will be the same. This black color wire, that is will be the reference electrode. Okay, and that will be coated by silver chloride, that will be connected to the pH meter, which is acting as a reference electrode. And this wire again which is covered with silver chloride, and which is dipped into this glass membrane with consist of a 0.1 molar HCl solution, and both the electrode will be connected to the pH meter to measure the pH of the solution. Okay, these are the figures of the combined glass electrode. Now we will see actually its construction. Into the construction part, the majority of pH electrodes available are combination electrodes, that both glass H plus ion sensitive electrode and additional reference electrode conveniently placed in one assembly. That means we can say that will be the combined glass electrode. That means there is no separate electrode. Okay, in one electrode they are connected both reference as well as the indicator electrode. For some specific applications, separate pH electrodes and reference electrodes are still used. Construction of combination electrode is in large part defined by processes that must take place when measuring pH. The difference of potential of solution across the two surfaces glass membrane is measured by using a closed circuit. Circuit is closed through the solution internal and external and the pH meter. However, for correct and stable results of measurements, reference electrode must be isolated from the solution so that they will not cross contaminate, and it is not an easy task to connect and isolate two solutions at the same time. Connection is made up through a small hole in the electrode body. This hole is blocked by porous membrane or ceramic asbestos in older models, that will be the ceramic wick. Internal solution flows very slowly through the junction, thus such electrodes are called flowing electrodes. To slow down the leaking in gel electrode, internal solution is in the form of a gel. The combined glass calomel electrode is represented as the combined glass electrode, that means the cell of that will be represented like this. See, silver chloride, that wire we have seen into the construction or diagram of the combined glass electrode, which consists of a 0.1 normal or 1 molar HCl glass membrane sample solution, and this half cell will be connected with the help of this two vertical line, that will be the salt bridge, and another half cell will be the saturated KCl, which consists of a mercurous chloride or mercurous chloride. Okay, the EMF of cell is given by the relation. What will be the relation? Relation will be the E cell is equal to E naught G minus ESC. That is, ESC means what? Saturated calomel electrode, and the EMF of cell is what? Is equal to E naught G means standard electrode potential of the glass electrode or the combined glass electrode. Then E cell is equal to E naught G minus 0.05921 pH. This relation we have already seen, minus ESC, that means standard electrode potential. ESC will be the 0.242 volt. Okay, when we put this value into the equation, therefore E cell is equal to E naught G minus 0.05921 pH minus 0.242. Therefore 0.0592 pH is equal to E cell minus E naught G minus 0.242. Then pH is equal to E cell minus E naught G minus 0.242 upon 0.0592. This is the relation, okay, of the pH for the calculation of the pH. By knowing E naught G and E cell, pH of the solution can be determined. Since E naught G varies with the type of glass material used, it is first determined by the combined glass electrode in vapor solution which is having known pH. Now we will see the working. In the working, there is no major task, just we have to dip that glass bulb into the solution whose pH is determined, and the pH of solution is measured using by the pH meter. Now, care of combined glass electrode. That means when we are using the glass electrode or the combined glass electrode, what care we should do, what should take, that we are going to see now. See, the bulb of glass electrode is very delicate, fragile, hence it is always enclosed with the outer plastic jacket. The dry glass bulb does not function, and hence it is always kept hydrated by dipping glass bulb in distilled water for 12 hours before its use. The combined glass electrode is to be standardized every time before its use by dipping in vapor solution of pH 7, 4 and 9.2 respectively. As pH of a solution varies with temperature, and hence temperature of solution must be maintained constant. So these are the cares that we should take when we are using the combined glass electrode. Now we will see applications in titrimetry. That means when we do the pH-Metry titration, that will be the strong acid, strong base, then the application of this pH-Metry. The pH of a solution depends on the concentration of H plus ions present in the sample solution. During the titration of strong acid, that is HCl, against strong base, that is NaOH, the pH of a known volume of strong acid solution is measured initially. When strong base like NaOH is added to the solution of strong acid, H plus ions from the acid combine with OH minus ions and form the base unionized water. That means simply the H plus ions will be low when we add the NaOH from the burette. As a result, H plus ion concentration of the solution steadily decreased and pH gradually increases. Okay, but hence the pH increases rapidly. However, near the equivalence point there is a rapid decrease in H plus ions. That means at the time of equivalence point, the H plus ion concentration will be gradually decreases, rapidly decreases, and the pH of the solution gradually steadily increases. After the equivalence point, NaOH added remains unreacted with ionizes completely to give OH minus ions, hence pH changes become gradual. That we are going to see into the graph. Thus, S-shaped curve is obtained during the titration of strong acid with strong base, and point of inflection pH is equal to 7 gives the end point of this strong acid strong base titration. Knowing the volume of alkali required for titration, strength of acid can be calculated. Plot of graph of pH against the volume of NaOH solution added is shown in the figure. Now we will see the figure, actual figure of the strong acid versus strong base titrimetry. See, this is the graph. On x-axis there will be the volume of NaOH solution added in ml, and on y-axis there will be the pH. See, the red color which started a shape curve from the pH 1, the pH of the solution will be initially gradually increases, but at the time of equivalence point, that means at the time of 50 ml NaOH, near the 50 ml NaOH added, at that time it sudden increases, rapidly increases, okay, up to the pH around 12, and again the pH of the solution gradually increases. Then we will get the S-shaped graph. Our end point of this titration will be the at pH 7 and volume will be the 50 ml. Okay, so this is the plot of the strong acid versus strong base titration. Now at the end we are looking the applications in biological and environmental analysis. Okay, so first one will be the pH of blood. The pH of blood is related to actual physiological condition of living beings. Hence, accurate measurement of pH of blood is essential to monitor physiological conditions of living beings. pH affects the several chemical and biological processes in water. Different organisms flourish in specific pH ranges. Most organisms prefer pH range 6.5 to 8 for their growth. Third, pH of water. The ideal pH range for safe water is become pH is greater than 6 and pH is less than 8. Fourth one, estimation of metal ions in water. Metal ions in very small quantities in water can be estimated complexiometrically by titrating them against disodium salt of PDTA at constant pH. Example for that, hardness of water can be determined by titrating with disodium salt of PDTA to estimate calcium 2 plus and magnesium 2 plus using erythrom black tea as an indicator at the pH 10. So these are all the applications of the pH-Metry. So dear students, thank you. Here this topic of pH-Metry will be end. Thank you.